Okay, so we'll start with this question. All of you, please try it. So the question is, we are given a first order LTI system. Sorry, it's not a first order, second order LTI system. And you have to find out the dominant pole of the system. All of you, please give it a try. So how to identify the dominant pole? So in order to identify it, first we have to find out what are the poles of the system. So how to find out the poles? We have to convert it to Laplace domain. Okay, we have to find out its transfer function, then we would be able to find the poles of the system, and then we will identify which one is the dominant one. Okay, now for that we will do the Laplace transformation. So we are given y double dot plus 14y dot plus 24y equals to u dot plus 3u. So what will be the Laplace transform of this? Considering all initial conditions to be 0. So we will left with s square y0 and y dash 0 are assumed to be 0. Okay. So the Laplace of double derivative of y will be s square y, then we'll have 14sy 24y equals to su plus 3u. Okay, so what will be y by u? It will be s plus 3 divided by s square plus 14s plus 24. Now can you identify the poles? Anyone? So we have to consider s square plus 14s plus 24 equals to 0 and solve this equation. So we can write it as s square plus 12s plus 2s plus 24 equals to 0. So we can write s plus 12 and 2s plus 12, which is s plus 12 and s plus 2 equals to 0. So s will be minus 12 and minus 2. So these are the poles. Now which among these is the dominant pole? And what, so
-2.
so first, what do you mean by dominant pole? Okay, now dominant pole means whose effect in the response of the system is dominant. Now if you find out the response of the system, so we know there are poles at -12 and -2. So in general we can say that yt will be something plus there will be something into e to the power -12t and plus something e to the power -2t. Okay, We can approximately say that the solution will look like this. Now as t goes to at some initial time, okay, now which one of these will go to 0 fastly? Can you identify? So if I plot e to the power minus 12t, okay, so it will start at some value, and with rate 12 it will converge to 0, okay. What about e to the power minus 2t? If I say this is the response of e to the power minus 12t, okay. Now what about e to the power minus 2t? Let's say it will start at some value, I don't know, but it will go to 0 more slowly, okay, because it has a factor of minus 2 and it is less than minus 12, so it will go to 0 very slowly as compared to e to the power minus 12t. So whose effect in the response of the system is dominant? Which exponential? This one, right? So which pole is the dominant in this case? Minus 2 or minus 12? It is minus 2, okay. And the thumb rule is that the pole which is near to the j omega axis is considered as the dominant pole. So we have pole at minus 2 and minus 12, and since minus 2 is closer to the imaginary axis or the y-axis, we say that minus 2 is the dominant pole, right? Any question? So this was about the dominant pole. Now for the question number 1, you have to find out the steady state value of the step response. For this question, you can first note this question, and for this one you have to find out the steady state value of the step response. We have already identified the transfer function, okay. So you have to give the step input and then find out the steady state value. So this is the transfer function. I will write it here, which is ys by us equals to s plus 3 divided by s plus 2 s plus 12. So this type of question we have already done earlier. Can anyone calculate the steady state value? So input we have to give step input, so it is 1 by s. So ys will be s plus 3 divided by s into s plus 2 s plus 12. With partial fraction we can break it into this form, and to get a we will multiply it with s and calculate the value at 0. At 0 it will be 3 by 24, which is 1 by 8. So A is 1 by 8. Can anyone find out the value of B? Okay, Aarti Kumari. Okay. What is B? So we will multiply y with s plus 2. Then we will left with this value and we will calculate it at s equals to minus 2. So we will get 1 by minus 2 into 10, which is minus 1 by 20. And last, see, you can calculate yourself. You will get minus 1 by 20. So we have A, B, C calculated. Now we can write y is as 1 by 8s minus 1 by 20s plus 2 minus 1 by 120 s plus 12. Now if we find yt, what it will be? Laplace inverse of 1 by 8s will be 1 by 8 ut we will get. What about this term? It will be minus 1 by 20 e to the power minus 2t, and for this term we will get minus 1 by 20 e to the power minus 12t, right? This is the response of the system. Now the question asked about steady state value. Okay, so by t, when t goes to infinity, will be this term will go to 0 and this term will also go to 0, right? So we will be left with 1 by 8. Okay, and 1 by 8, which option is correct? Third one. How many of you calculated it correctly? 1, 2. Okay, so very simple one. We have already done these type of questions. So the third question is, in the unit step response of the above problem, find out the coefficient that multiplies the exponential term whose exponent is the dominant pole. So in this question, you have to find the coefficient whose exponent is the dominant pole. So this one is the solution, right? What will be the coefficient of the exponent of the dominant pole? We have already find
20.
yes, we have already calculated the dominant pole of the system. What was the dominant pole?
Minus 2.
It was minus 2. So corresponding to minus 2 pole, what is the exponential? The exponential is this term, right? And what is the coefficient of this exponential? It is, coefficient
Minus
is
1 by 20.
this term, right? So the answer is minus 1 by 20. So which option is it? A? Okay. So any problem? Anyone?
Ma'am, for coefficient C, I have got minus 3 by 40.
See, no. You have to find the coefficient that multiplies the exponential term whose exponent is the dominant pole. So the dominant pole for this transfer function we have calculated The dominant pole, the poles were minus 12 and minus 2. So which one is the dominant pole?
That part I understood. That
Yes.
exponent e to power minus 2t.
Yes. So no, I
Here,
have
when we are
calculated
a
the,
b c,
yeah, I got B as minus 1 by 20.
in
Here you
c,
can see.
I have got minus for 3 by 20, 40.
No, the dominant it is 1 by 20. How much you are getting?
Coefficient b, I have minus 1 by 20. I am talking about
Yes,
coefficient
yes,
c,
yes. What are you getting? C
minus 3 by 40.
minus 3 by 40. Let's calculate it. So for C, we'll have S plus 3 divided by S into S plus 2 at S equals to minus 12. So it will be minus 9 divided by minus 12, and it will be minus 10. Okay. So 339, 3 fours are 20. Oh yes, it is 3 by 40. Sorry, you are right. It is 3 by 40. C is 3 by 40. Thank you, Neeraj. So you can correct this value as 3 by 40. So it's just an MCQ question. The zero of transfer function in the right half complex plane. If the zero is in the RHP, then such zero is called,
Non-minimum phase 0.
yeah, non-minimum phase zero. Okay, correct. So this for this first order differential equation, you have to find out the approximate transfer function. So we have delay in the input. So if there is this type of delay, what will be the approximate transfer function for such differential equations or such systems? What will be the Laplace of system when there is a delay? For example, in this case, we have delay of zero point 0.2. In U, there is a delay of zero point 0.2. What will be the Laplace of this type of function? So for such functions, if there is a delay of capital T, then the Laplace will be e to the power minus ts us. Okay, so this is the general formula. Now you can now directly apply it here. So for y dot plus 2y equals to ut minus 0.2, we have sy plus 2y equals to e to the power minus 0.2 s us. So y by u will be e to the power minus 2s by s plus 2. But there is no such option, right? We have to approximate this exponential term using payday approximation. So anybody know what this approximation is?
No, madam.
Okay. So payday approximation basically tells us that for any function fx, any function we can approximate as a polynomial, right? So it can have a0 plus a1x plus a2x square divided by 1 plus b0 x plus b1 x square, like that. Okay, and then we have to ignore the higher order terms, so because we have to do the first order approximation, so we will consider x ki power 1 terms only, right? And then we have to approximate, we can approximate any function like this, okay, by equating the coefficients. And for exponential one that we have in this case, so what is the how can we expand e to the power x? What is the Taylor expansion of e to the power x? It is 1 plus x square by factorial 2 plus x cube by factorial 3 up to n terms, up to infinity we can go, but we have to approximate it to first order, right? So first order approximation will be 1 plus x only. Now in this case we have something like e to the power minus x, so it will be what? We can write it as 1 by e की power minus x, so it will be 1 by 1 plus x, sorry, minus x, right? So this way we can approximate it. Now if you have e to the power, if you have e to the power minus x, we can write it as e की power minus x by 2 and e की power x by 2. We can write it.
Yes.
So this expansion is 1 minus x by 2 and this expansion is 1 plus x by 2. So it is basically 2 minus x by 2 plus x. So now in place of x we have 0.2 s, right? So it will be e to the power minus 0.2 s can be approximated as, this is not equal to, this is the approximation, will be 2 minus 0.2 s divided by 2 plus 0.2 s, right? So in this way we can approximate an exponential. So this is polynomial in denominator and polynomial in numerator, so this is nothing but Pede approximation, and we have considered only the first order terms. We have considered x cube terms up to x cube power 1. We have neglected all the other terms, right? So this is first order. Okay. So in any transfer function, if you have a delay, you can approximate the Laplace of that term as 2 minus x divided by 2 plus x, where x is nothing but this term. In this case, we have 0.2s, right? Now, for this question, now can you calculate the transfer function? So now it is very easy. You have all the Laplace transforms. You have to just put their values, put these transformation and calculate the overall transfer function. Any one of you calculated?
No, we have to replace e to the power minus 0.2s by this approximate value.
Yes, this
No.
approximate value.
Then we'll get an expression. There is nothing to calculate after that one.
No expression is coming matching the options. Okay, let's solve it then. Okay, Shishir is saying D. Okay, let's calculate. So we have y by u given like this. So y by u, we can write this 2 minus 0.2s divided by s plus 2 and 2 plus 0.2s. We can simplify it at like we can take common as so we can write it as like this first, and then we can take 10 as common. So first we can cancel out 2 factor from the numerator and denominator will come out, so it will cancel out, right? So we'll be left with 10 minus s plus 2, and it will be 10 plus s. So it is 10 minus s. So option D, we are getting option D. So what I have done, I have taken the LCM as 10, so it was 20 minus 2s divided by s plus 2, 20 plus 2s divided by 10, so 10 10 cancelled, and 2 is also cancelled, so we're left with 10 minus s by s plus 2, 10 plus s. Is it clear to everyone?
Yes, ma'am.
Okay. So this is the approximate transfer function, right? This is the approximate transfer function. Always take care of it. This is not the actual transfer function. Actual transfer function is this one. We have approximated the exponential term using first order approximation, and so we are getting this one. Now can you identify whether this system is minimum phase or non-minimum phase?
Non-minimum phase, ma'am. It has
Yes.
zeros on the right side.
It has a 0 at s equals to 10, which is in the RHP. So it is a non-minimum phase system. Okay. So we have a negative unity feedback system with plant transfer function given as this, and the controller transfer function given as this. You have to find out the closed loop transfer function. So in these type of question, be very careful while reading the question, whether it is plant transfer function, controller transfer function, open loop transfer function, closed loop transfer function. Be very careful. So here we are given plant transfer function and controller transfer function, and you have to find out the closed loop transfer function of this system. So this one is easy. Please try it yourself first. Any answer? So for a general closed loop system, how can we represent the block diagram? We have a plant transfer function first, right? Then some output we getting. Now if it is a closed loop system, there is a feedback whose transfer function is Hs. Then we have some reference signal RT, okay, and if there is minus, then we will get some error signal, to which we have the controller CS, and this controller output is fed to the plant, right? So in this case we are given what? We are given plant transfer function. So plant transfer function is this one, and we are given the controller
CS.
transfer function, which is CS, and we have to find the closed loop transfer function. Closed loop transfer function means this
G
ys by
RS.
rs. So you must have gone through the lectures. There you must have um, seen that the closed loop transfer function, if we have the negative feedback, consider, be careful that we have a negative feedback. In that case, the closed loop transfer function is given as 1 plus gs divided by 1 plus gs into hs, where gs is ps into cs. Okay, so plant transfer function multiplied with controller transfer function, generally we call it as gs, right? So first in this case we have to calculate gs, and then we can calculate the closed loop transfer function with unity feedback. Okay, so what is ps into cs? It is very straightforward. ps is 2 by s square plus 3s, and cs is 4 plus s. So gs will be ps into cs, which is equal to 2 into 4 plus s divided by s square plus 3s. Now we have gs and hs. What is hs?
1.
Yes, here we are given unity negative feedback. So negative we have already considered, and feedback is unity, means h is equal to 1. So h is equals to 1. Now calculate the closed loop transfer function. We have g, we have h. Calculate g by 1 plus g into h.
C.
C. How many of you are getting option C? Okay. Okay, let's check it. So we have to find out g by 1 plus gh. So this will be equal to 2 into 4 plus s divided by 1 plus 2 into 4 plus s divided by s square plus 3s. So this will be given as okay, it is s square plus 3s also. So we'll be left with 2 4 plus s divided by s square plus 3s plus 2 4 plus s. We can combine the terms. So it is 8 plus 2s divided by, it is 2s, so it will be 5s plus 8. Okay, so which option is correct? Option C. The next question. So in the earlier problem, we have considered the negative unity feedback. Now, what will be the closed loop transfer function if we have unity positive feedback? So for this problem, whose controller and plant transfer function is given as this, find out the closed loop transfer function when we have unity positive feedback.
Option second.
Many of you are getting option B. Okay. So, can any one of you tell me what is the closed loop transfer function with positive feedback is? So, it is what? GS divided by?
1
1
minus
plus
GS.
GS into HS.
No, 1 plus GS into HS is in the case of negative feedback. We have positive feedback.
Okay, then
So
there
we
will be
1
have
minus sign.
minus
1
GS
minus
into
GS
HS.
into HS, right? Now you can easily calculate GS was. So here only we can calculate G by 1 minus GH. So it is 2, 4 plus S divided by S square plus 3S, and 1 minus 2, 4 plus S divided by S square plus 3S. So we will get same numerator, but in denominator we will get minus 8 minus 2s. So it is 8 plus 2s divided by s square plus s minus 8. So s square plus s minus 8. So which option is correct? Option B. So for the earlier two questions, which statement is correct? So the first statement says that the closed loop system is stable with negative feedback but not with the positive feedback. So we have to comment on the stability basically, whether the closed loop was stable or unstable, or the negative feedback closed loop system was stable or unstable, and about the positive feedback closed loop system as stable or unstable. We have to comment on the stability of these two. So this is the transfer function for negative feedback closed loop transfer function, and this is for positive feedback. So how to comment on the stability of the system? Weber stability. What we need to check?
Pole.
We have to check the poles. So what are the poles for this one? So I will write it as negative and I will write it as positive. So this one is A and this one is B. So what are the poles of A, system A?
Minus 2.5.
Okay, let's calculate. So s square plus 5s plus 8. So can you factorize it? I think no. So it will be minus b, which is 5, plus minus under root b square minus 4ac divided by 2. So it is minus 2.5 plus minus 25 minus 32 is 7 minus 7. It is. Okay, so it is minus 2.5 plus minus root 7I by 2. So where are the poles of this system? Is it in the RHP, LHP, on the imaginary? Where is it? So this I am calculating for negative feedback first. So one pole is obviously at RHP because we'll get minus 2.5 and minus something. And another one is minus 2.5 plus something, and that something is imaginary. So we have pole at So let's suppose it is minus 2.5. We are having pole at here and here, right? Minus 2.5 root 7 by 2 and minus 2.5 plus root 7 by 2. So the poles are lying on LHP or RHP?
LHP.
LHP, yes. The poles are on the left half plane. So this system is Weber stable or not?
Yes, ma'am, it is stable.
Yes, it is Weber stable because all the poles are on the left half plane. Now what about the system B?
One pole is in RHP.
Okay, let's. So the characteristic equation of this one is s square plus a is minus 8. Again we can write um, okay, so it is minus 1 plus minus root 33 by 2. So one pole will be minus 1 minus root 33 by 2 and another pole will be minus 1 plus root 33 by 2. So this term is negative, okay. And what about this term? Root 33 is greater than 1, right? Anyhow it is greater than 1. So it will shift the pole. So this term will be positive. So we have one pole on the left half plane and other is on the right hand plane. So is it Weber stable or not? So the Weber
No.
stability says that all the poles should lie on the left half plane. So here all the poles are not lying on the left half plane. Only one pole is lying on the left half plane. And we have another at the RHP. So this is not Weber stable. Okay. So which option is correct?
First.
Yes. So we have seen that for negative feedback system, in this example, with negative feedback the system was stable, and for positive feedback the system was not stable. Okay, so option A is correct. So you have to find out the open loop transfer function for problem 6. What was problem 6? So for this one, calculate the open loop transfer function. What is the open loop transfer function for this controller and plant transfer function given here? Calculate the open loop transfer function. So what is the open loop transfer function? If I draw the block diagram, what do you mean by open loop transfer function first?
CS into PS into HS.
Okay. And if I want to ask you about in this block diagram, suppose we are talking about negative feedback. So this one is CS, this one is PS, and this is HS. Okay. how can we make this system open loop? If we cut open this feedback, then the system will be open loop, right? Now if we
Yeah.
draw the open loop structure, how it will look like? It will look like, here is output we are taking. So this was CS, this was PS, and if we cut this, then we can, all these come in series. Okay, so these all blocks are in series, in cascade. Then what is the overall transfer function in this case? These get multiplied, so it is CS into PS into HS. So this is the open loop transfer function. Now CS into PS we generally term as GS. So it is GS into HS, right? So in our problem HS was 1 and GS we have already calculated. It was
2
2
into 4s
into,
by s square plus 3s.
yes, square plus 3s. So which is the correct option? We have calculated the open loop transfer function.
B.
This is the open loop transfer function equals to GS into HS. B, is it B? So 8 plus 2s plus, yes, option B is correct. Okay. So again, for negative feedback we were asked about the open loop transfer function. Now the second question is for the positive unity feedback, what will be the open loop transfer function? So this is your question. So problem 7 was the same problem with positive unity feedback. In that case, what will be the open loop transfer function?
And B.
B means it will be same, right?
Yes, ma'am.
Yes, because the open loop transfer function is GS into HS. Now since we are not giving any feedback, that means we are not concerned about whether it is negative feedback or positive feedback. We have opened the system. We are not providing any feedback. So why we care about is it positive or negative? It doesn't matter. So it remains the same, right? Unless and until G and H are same, it doesn't matter whether it is positive feedback or negative feedback. Open loop transfer function remains the same. So in this case also, transfer function, open loop transfer function remains the same. So for the next question is for a stable first order linear time invariant system, which among these options is correct? So we have, what are the keywords? We have a stable first order LTI system. So system is linear time invariant first order and it is stable. Now comment on which among these options is the correct one.
B.
B. Okay. So the first one, what it is saying? It is saying the unit step response always converges to zero as time increases to infinity. Is it so? Let's take an example and check. So we have a first order LTI system and it is stable. So the pole is in the left half plane. So this can be a possible example of a stable first order LTI system. Now we are given the step input. So step input will introduce it like this. Okay. So what will be the response of the system? So there will be one constant term and then we have some coefficient and e to the power minus 2t. Now t goes to infinity, so this term will go to 0, but there will be some value here. Okay, and the statement 1 is saying the unit step response always converges to 0 as time increases to infinity. So we have found out one counter example where time is going to infinity but the response is not 0, it is converging to some value which is not necessarily 0, right? So this option is not correct. It will not converge to 0 always, it will converge to some value. It can converge to some value, right, which is not 0. It is possible. And what is the second option? The unit impulse response converges asymptotically to a non-zero value as time increases to infinity. Okay, so let's check this one also. So let's suppose the first order transfer function, again we have 1 by s plus 2, right? It is a stable LTI system. Now the step response will remain the same as it is because us is 1 in this case. Now for such systems, what will be the response? It will be some factor multiplied with e to the power minus t2, right? It will always be like this. So as t goes to infinity, system will always go to 0 because this term is 0 and there is no term here. There is no term here. So this option is also not correct because it is saying that the unit response converges asymptotically to a non-zero value. But we have seen an example where it is going to 0 value. So it is also not correct. What is the third one? The magnitude of the unit ramp response tends asymptotically to a finite value as time increases to infinity. So unit ramp response is what? A unit ramp is an unbounded input. So an unbounded input does not necessarily mean that it will converge to a finite value. It can be unbounded. So this one is also not correct. Okay. The last option is it has one pole in the LHP. Is it true or not? So we are given a stable first order LTI system. So what do you mean by first order LTI system? How many, what is the order of the denominator? So it is first order means the order of denominator will be 1 only. So it will be numerator can be anything, it will be b1s, right? So this type of systems are called first order system because s की power 1. And now it is saying that it is stable. It is stable means its pole will be in the
Left half plane.
left half plane, right? So which option is correct? So it will have only one pole because it is first order, and since the system is stable, that pole will always lie on the LHP. Any doubt, anyone? Okay. So this question saying that I think I have. Oh, yes. Okay. So the question is saying that at time instant equal to thrice the constant of a stable first order LTI system. So we have a stable first order LTI system and time is thrice the time of a constant. Okay. The ratio of its unit step response value to final asymptotic value of its unit step response is. So what the question is saying? The question is saying that we have a system, we have provided the unit step input, and then we have to find the ratio of unit step response to the final steady state value. And at what time? At thrice the time constant. What will be the ratio? So let's suppose the transfer function is gs. Okay. Now in general, how a stable linear time invariant system looks like? Is there any general notation for that? You must have seen in the lecture that we can denote a first order system as 1 by st plus 1. Okay. And then we are providing unit step input. So unit step input will be, with unit step input the response will be 1 by s into st plus 1. Okay. So what will be the response in time domain? What will be yt for this one? It is a by s plus b by st plus 1. Okay. What will be a?
It is
Okay, sorry, there was a connection issue from my side. So are you able to see my screen?
Yes, ma'am.
Okay.
yes.
So what will be A and what will be B?
E will be 1 and B will be minus T.
Okay. So A will be it is 1 and B will be it is minus T. Okay.
Yes.
So let's write it again first here. So ys is now 1 by s minus t by st plus 1. Okay. So what is yt? It is 1 minus, if we divide the second term numerator and denominator by t, what we will get? We will get 1 by s plus 1 by t. Can we write it like this?
Yes.
Yes. So now for this one, yt will be 1 minus e to the power minus t by capital T. Okay. So this is the step response. This is the step response of a linear time invariant system. Then we have to find out at t equals to 3. Okay. So in this case, which is the we have to find a time instant equal to thrice the time constant of a stable system. So what is the time constant?
Capital T.
Yes, the time constant is this coefficient that you are saying is called the time constant, right? Okay, so at t equals to 3t, what will be yt? So how can you calculate y of 3t? It is 1 minus e to the power minus 3t by t only, which is equal to 1 minus e to the power minus 3. So can anyone calculate in decimal what is 1 minus e to the power minus 3?
0.950.
0.950. Okay.
Oh,
And what is the final asymptotic value? Means at t tends to infinity, let's write it again. At t tends to infinity, what is y? It is, this term will go to 0, right? At t goes to infinity,
1.
so we'll be left with 1. So what is the ratio? We have to find the ratio of y at 3t divided by y at infinity. Okay, because the question asked about the ratio at a time instant equal to thrice the time constant of a stable first order LTI system, the ratio of its unit step response to the final asymptotic value, means y of 3t divided by y of infinity. It is nothing but 0.95. Okay, so which option is correct? It is C.
Option C.
Yes. So any doubt? And why we have considered this system? Because we are given a stable, where it is, we were given a stable Stable means the pole should lie on the LHP, right? So that's why we have considered this type of LTI system, because its pole will lie on minus 1 by T. Okay, so it is on LHP. T is some positive value. So for such stable LTI system, we calculated y at thrice of the time constant and y at infinity.
Now for question number 11,
Mm-hmm.
we have discarded option number 2, ma'am. But for unit step response,
Mm-hmm.
there will be a always be a constant term.
The unit step response always converges. No, it is saying it always converges to 0. If there is always, means there cannot be any situation where it is setting to a non-zero value. But we have seen an example where it is converging to a non-zero value. So that's why we are discarded, because it was saying always.
Now,
So it is not
in
true.
ma'am, option B, ma'am. Why we have discarded option B?
So option B was saying the unit impulse response converges asymptotically to a non-zero value. Here also it is saying this such things always happens in general, but here also we have seen that no, it converges to all zero value, exactly at 0. So this option is also not true, because it is saying that this happens only, but no, this doesn't happen only. There can be a situation where it converges to 0. So that's why we have discarded option B.
But there is first option there is the word always, and the second option there is no word always. So the first option says definitely, and second option is not that definite statement, ma'am.
It is not
That
definite statement, but it's also not true, right? It is converging to a 0 value.
ma'am, for some step input, there is always a term, constant term comes out, constant term in the output, ma'am. All the questions that we have solved, there is always a constant term.
Yes,
Mm,
there are always. For unit step, unit impulse response, see, we have to just find a counter example if that exists, so we can discard that statement, because that statement is saying it converges to a non-zero value. No, it is not converging to a non-zero value.
For example, the
Yes, this one is example. This example I have shown you here. We have a stable LTI system, so its impulse response will be same, right? And what will be its time response? Just minus 2t. So as t goes to infinity, this explicitly converges to 0, which is 0. And it is
okay,
saying it
ma'am.
is converging to a non-zero value. So this is not
Okay,
true.
ma'am.
Clear now?
Okay, ma'am. Thank you.
Yes. So we have solved up to 12. Okay. So in next question we have transfer function, and we are given unit step input. Then you have to find out the difference between the input and the output asymptotically. So the difference of the input and output as t goes to infinity will be equal to, So very simple question. Okay, the transfer function g of s is, plant transfer function is 1 by s plus 2, and input is step input. So what will be ys? 1 by s into s plus 2. This is the response. Now find out y of t again. It will be something by
One by
s plus something by s plus 2, and we can directly fit it as, I think it will be s by 2 minus s by 2. Is it correct?
yes, ma'am.
Okay. So this is ys, then yt will be very simple, 1 by 2 minus 1 by 2 e to the power minus 2t. Okay. So this is the step response of this system. We have to find out the difference between the input and the output asymptotically. Asymptotically means we have to find out the steady state value. Okay. So asymptotically means we have to put t as infinity. Then what will be the value of response? It will be, this term will go to 0. So it will be 1 by 2. Now we have to find out the difference between input and output asymptotically. So the input was, ut was step input. So for all t, as t goes to infinity even, the value is 1, and yt is something, and it is converging to value 1 by 2, and it is starting with 1 by 2 and it is converging to 1 by 2 as t goes to infinity, right? So what is ut minus yt as t goes to infinity? It is 1 minus 1 by 2, so it is 0.5. So option B was correct. Clear to everyone?
Yes, ma'am.
So for this system, again find out the steady state value.
Ma'am, can you repeat in this graph?
This graph, okay,
Yes.
how I have drawn it. So let me draw it again. So what do you mean by step input? Step input means for all t the value is 1, right?
Yes.
And yt, here also, from equation also you can find out that at t tends to infinity, the value of output will be, y at infinity it
1 by
is 1 by 2. Now how I have drawn it, so you see, so on the x-axis we have t, on the y we have yt, right? At t equals to 0, what will be the value of y? At t equals to 0, we will have 1 by 2 minus e की power 0 is 1, so minus 1 by 2. So sorry, I have drawn it incorrectly. So just for reference only I drawn it. So it will start at 0, right? And at y t tends to infinity, it is settling to 1 by 2. So it will start at 0 and it will settle to 1 by 2, right? So what is the difference of ut minus yt as t goes to infinity? It is 1 minus 1 by 2. Okay?
Now clear.
Yes.
Yes.
So now try this problem. So very simple it is. We will find out the transfer function of this differential equation, which is sy plus 4y equals to u. So y by u will be equal to 1 by s plus 4. And u is a step, so y will be 1 by s into s plus 4. Again, what will be yt? It will be 1 by 4 minus 1 by 4 e to the power minus 4t. Is it correct? Because you can write it as 1 by s plus b by s plus 4, and a you will get 1 by 4 and b you will get minus 1 by 4. Is it true? Please check the coefficient. I have just
Yes, ma'am. Yes, ma'am.
so a 1 by 4 will be 1, and yes. Okay, so what is the steady state value? As t goes to infinity, again y will be 1 by 4 only, which is 0.25. Now from transfer function only can you identify the steady state value. So this system is Bibo stable, right? Because the pole of the transfer function is lying on the left half plane. Okay, so it is Bibo stable. So for Bibo stable system, we can directly apply the final value theorem. So what was final value theorem? So the response yt as t goes to infinity can be given as
Ys as s tends to 0.
s
Limit
into
of
ys
s.
as s
Limit
tends to
s
0.
tending to 0.
So in this case, ys is this, and if we multiply it with s, it will be 1 by s plus 4. And if we put s equals to 0, we'll left with 1 by 4. So directly from transfer function also, you can find out the steady state value, or the value as t goes to infinity. But first be sure that the transfer function is, or the system is Bibo stable. Okay, so the correct answer is A. So for this LTI system, identify which option is true. Okay, let's try this problem. The system is y dot plus 4y equals to ut. Now we can write it as, so y by u is 1 by s plus 4, right? So there's okay, so this system is Weber stable or not? We have a pole at s equals to -4, so this one is Weber stable, right? Now the first option is saying that its response has an oscillatory component. Its response has an oscillatory component. Is it true?
No, ma'am.
Can you identify one input where its response will not be oscillatory? Just give u as impulse input. So y will be 1 by s plus 4 and yt will be e to the power minus 4t. So is it oscillatory? No, not oscillatory. So we have identified one input where this response is not oscillatory. So this option is not correct. Its response doesn't have any oscillatory component, at least for one input we can say. And what about the second option? It is unstable, it is saying. So just now we have seen its pole is at LHP, so it is Bibo stable, so it is not unstable. So the third option is its settling time is 1 second. So what is the settling time then? How can we calculate it?
No, first we have to find the time period.
Time constant you are saying, right? So
Oh, yes, ma'am. Yes, ma'am.
so first we have to convert the transfer function in the standard form. Okay, the standard form is something like a by bs plus 1 kind of thing. Okay, so for this one, let's call it as gs. If we divide the numerator and denominator by 4, we will get 1 by 4 divided by s by 4 plus 1. So we got the standard form. So what is the coefficient of s here? Because time constant, so instead of, let's write it the standard way. Okay, so what is the coefficient of s? This is the time constant. So here what is the coefficient of s? It is,
1 by 4.
so time constant t is 1 by 4 second. So what is the settling time in terms of time constant? It is, that is a formula for it. If we know the time constant, we can find out the settling time. It is 4 times of t. Okay, and t is 1 by 4, so 4 into 1 by 4 second, that is 1 second. So the settling time is 4 second for this system. Means, let's suppose for, in order to settle at the steady state value, let's suppose this is the steady state value. So to settle around 2% of that steady state value, it will take how much time? It will take 1 second. Okay, again this is not, may not be the graph of this example. I'm just saying it for understanding purpose. Okay, so to settle around 2% of the steady state value, it will take 1 second. So this is the settling time. So far option third is correct. What about the last option? The steady state value of its unit step response is 1.
False.
So what is the unit step response? So you had to calculate,
1 by 4.
okay, and in the earlier example only we have calculated. So the steady state value was 1 by 4, and it is saying it is 1, which is not correct. So this option is incorrect. Okay. So for this problem, there is a
Ma'am,
unit. Yes.
in the previous question, the S coefficient is taken as time constant. You say this is a standard notation. How this?
Sorry. Can you repeat?
This g of s is equal to 1 by 4 upon s by 4 plus 1.
This one.
Ah, yes, yes.
Yes, we have to ensure that. So this is a first order system. So there will be s ki power 1. And we have to ensure that there is 1 here. So for that
Yes.
purpose, we have divided everything by 4, because in this case we have 4 here. So divided with 1 by 4 only. Divided with 4 to get into the standard form. Because the coefficient of s is the time constant.
But in the standard form, it is 1 upon s ts plus 1.
Yes, that doesn't matter. Here we can have anything. This is just a scaling factor only, no?
Okay, ma'am.
Okay, so for this system, the unit impulse response, so there is a unity feedback system whose unit impulse response is given by this. You have to identify the open loop transfer function. So if you understand what is unit impulse response and what is unity feedback system, then you will be able to solve this problem very easily. Okay, so read this question again and again, then try to figure out what actually is given to you. So first we have a unity feedback system. Okay, and then we are given that for that unity feedback system, we will assume it as negative feedback only. We are provided with the unit impulse response, which is given like this. Okay, so the unit impulse response of a unity feedback system is given as this value in time domain. So first let's figure out what it is in S domain because all the answers are in S domain. So we will do the Laplace transformation. What will be CS? So what will be the Laplace of e to the power minus t? It will be, let's do it separately otherwise. So what is the Laplace of e to the power minus t? It is 1 by s plus 1, right? And what is the Laplace of t of e to the power minus t? It will be minus df by ds. And f in this case is Laplace of e to the power minus t. So this is the general formula, right? We know if there is multiplication with t, there will be differentiation with minus sign. So we have to differentiate this one. So it will be minus s plus 1 whole square, and then we have to incorporate another minus, so it will be plus. Okay. Okay. So Laplace of t into e to the minus t is 1 by s plus 1 whole square, and there is minus, so it will be minus 1 by s plus 1 whole square, right? And what is the Laplace of this? It is very simple, 2 by s plus 1. Okay. So this is the unit impulse response. Now let's do it in simplify it further by taking LCM. So it will be 2s plus 1. So 2 minus 1 is 1. So 2s plus 1 divided by s plus 1 whole square. Okay. So this is the unit impulse response of a unity feedback system. So what does it mean? What actually is given to us? Can anyone comment?
Closed loop transfer function.
Yes. Unit impulse response means nothing but the, it is equal to the transfer function only, because in that case input is rt just sorry 1, input is 1, so the response is equal to the transfer function only, right? So this is the unit impulse response of unity feedback system, means it is the closed loop transfer function. Okay. So for this closed loop transfer function, we have to find out the open loop transfer function. Now what is the open loop transfer function? We have earlier seen the open loop transfer function is given as gs into hs, if gs is equal to the controller transfer function, if it is there, multiplied with plant transfer function. Now we have to find out gs into hs. And we know that the closed loop transfer function for a negative unity feedback system is written as gshs upon 1 plus gshs. So we have to find out gs into hs. Let's call it as p, ps. So we are given with ps by 1 plus ps. Okay. And this we are given as 2s plus 1 divided by s plus 1 whole square. So now can you find out ps from this equation? Because
2
ultimately we have
plus
to,
1.
yes,
That numerator.
sorry, there's something wrong.
It is only g of s upon 1 plus g of s into h of s.
Oh, okay. Yes, yes, yes. Thank you. Js upon 1 plus GSHS. Correct. So it is unity feedback. Means HS is what? 1 only.
Yes,
So
ma'am.
PS equals to GS. So this remains the same. Now find out what is PS.
And PS is the numerator 2s plus 1.
No. PS divided by 1 plus PS equals to this thing. You have to find out what is PS. It will not be only numerator, there will be something else also. If it was PS by 1, then you could have said that PS is this whole thing. You have to equate the left hand side and right hand side. So let's solve it. So we have PS s plus 1 whole square equals to 2s plus 1 plus PS into 2s plus 1. Right? We have done the cross multiplication. Then we can take the PS terms on the left hand side. So it will be plus 1 whole square minus 2s plus 1. Okay, and this will be 2s plus 1. So PS into, so this will be s square plus 1 plus 2s minus 2s minus 1 is equal to 2s plus 1. Here I have expanded the square term. So it is, these all will cancel out. So it will be s square equals to 2s plus 1. So PS equals to 2s plus 1 divided by s square. Okay. So which option is correct? The open loop transfer function is B, 2s plus 1 divided by s square. Right? Clear to everyone?
Yes, ma'am.
Okay, so
Yes.
this is the last question of today's session. Okay, sorry, because here I have written, we are left with two questions. So this one is very easy. 17, you can do it on your own. It is very simple. So we are given, for this system, we are given the step input and the output is yt. Then you have to find out the value of dy by dt at t equals to 0. How can we do it? So very simple. Ys will be nothing but s minus 2, s plus 1, s plus 3, right? Then we will find yt. Okay. Can anyone quickly tell me what will be yt? So it will be a by s plus b by s plus 1 plus c by s plus 3. So a will be minus 2 by 3. Please correct me if I do something wrong. B will be minus 1, so it is minus 3, minus 1, 3 minus 1, 2, minus 2, which is 3 by 2, and C will be 5 divided by minus 3 minus 2, so it is minus 5 by 6. Is it correct? So yt will be
Yes.
minus 2 by 3, so yt will be minus 2 by 3 plus 3 by 2 e to the power minus t minus 5 by 6 e to the power minus 3t. Okay, so what will be derivative of y? Y dot will be, so this constant term, derivative of constant is 0 only. Okay, plus this derivative will be minus 3 by 2 e to the power minus t. And what about this term? It will be 5 by 6 into minus 3. So minus minus plus, and it is 5 by 2. Oh, sorry, 5 by 3. No, 5 by 2 only. E to the minus 3t. So what is the value at t equals to 0? Put t equals to 0. Y dot at t equals to 0, it will be minus 3 by 2 plus 5 by 2, which is nothing but 1. Okay. Clear, everyone?
Yes, ma'am.
Okay, so
Yes.
the last question. So here the input is minus 3 e to the power minus 2t into ut, and ut is a unit step function, and it is applied to the system whose transfer function is s minus 2 by s plus 3. Now we know that the transfer function is calculated by putting all the initial conditions as 0. Okay, but it is saying that the initial value of the output, that is response, is minus 2. Then you have to find the value of output as t goes to infinity. So you are given an input, you are given the transfer function, and you are given that the value of response at t equals to 0 is minus 2. Then you have to find out the steady state value of the system, of the response. So let's do it because we don't have much time. Okay, so US is given as, so the input is, sorry, what is the input? Input is minus 3 2t ut. Okay, so let's call it capital UT. So what is U of S, where UT is step? So it will be 1 by S, and there is this factor, so it will be minus 3 by S minus 2. Okay,
Then the transformation of ut will give one more time, 1 by s.
no, it is 1 by S, right? But there is this exponential term, because of which s will be shifted by which value? By 2. So minus 2. E to the power 2t, it doesn't have transfer function, it just shift s by this factor. So and it is applied to some function, and this function is ut in this case, which is step. So without exponential, the Laplace will be 1 by s, but we have e to the power 2t, so the Laplace will be s minus 2. Correct?
If we use the convolution property, then the product of two functions when undergo Laplace transformation,
No, no, no.
it results.
In Laplace you can do the product thing, right? So earlier we are doing the same thing in all the problems. We have something like that, okay? So okay, let me. So in earlier problems we were getting something like s plus 3, okay? So what was the Laplace of this one?
E to the power
Inverse
minus
Laplace.
3t.
E to the power minus 3t only.
Yes, ma'am.
There is ut also everywhere, because we are only saying for t greater than equal to 0, okay? Because we are doing Laplace from 0 to infinity, not from minus infinity to infinity, okay? So there is always ut here, which says that the response is this for t greater than equal to 0. So that's why we are having inverse Laplace of this function only doesn't have uh, this Laplace. The Laplace is coming because of ut, because Laplace of ut is 1 by s, and this exponential term do the shifting, okay? So in the list of Laplace transform, you will see that if there is ft and we have some exponential of minus, let's say, as, then inverse Laplace of this will be Laplace of s shifted by a value, okay? So this is the general result. Now it is clear to you?
Okay, ma'am.
So this is the input in this case, and sorry, and the transfer function is s minus 2 by s plus 3. So response will be s minus 2 s plus 3 into us, and us is minus 3 s minus 2. So this will cancel out, and it is minus 3 by s plus 3. So this is the response. Now okay, now the thing is, this transfer function is given when the initial condition is assumed to be 0, okay? So this is equal to y by u. So y into s minus 2 equals to u into s plus 3, okay? So now what if the initial condition was not 0? So this term generally means y dot minus 2y equals to u dot plus 3u, okay? Now do the Laplace transform without putting initial condition to be 0. What would be the Laplace transform of this one? It will be sy minus y0 minus 2y, and it is su s minus u0 plus 3u. Okay, we have here considered that because in question it was saying that the initial value of output is -2, so that's why, means that y was not 0 at that time at t equals to 0, so that's why we have considered the initial values also. Okay, so in question it is given that y0 is -2, so we will put y0 as -2, so this will be +2 -2y su. And what will be the input at t equals to 0? What is the input at t equals to 0?
Mm, 0.
Is it 0 or is it -3? So here is the input, right? How is ut defined? Step input is defined as at t
Oh,
equals to 0 minus, just before 0 it was 0, but at 0 it becomes 1. But in this case, at t equals to 0, if you see, it is 3 minus 3 e to the power minus 2t ut. So at t equals to 0 minus, it was 0. At t equals to 0, it is -3.
-3.
So you can take the value at t equals to 0 minus or t equals to 0 minus as 0 and t equals to 0, it is -3. So you can take any one of these values, the answer will be same. Okay, so in this case, let's take at t equals to 0, it is -3, so it is +3, right? And 3u. Then let's take the y as it is s minus 2, it is s minus 2, and it is u um, s plus 3. Okay, and here we have plus 1. Okay, something is wrong anywhere. 3. Okay, so y is u into s plus 3 by s minus 2. Something is wrong, I think. S plus 2. U is oh, here I have done wrong. Okay, in this step you can see, so here will be, if we do the cross multiplication, what I have done, it should be y into s plus 3, right?
Yes.
Yes, so this step is wrong. Anyways, you can correct it. It is s plus 3 us minus 2. Okay, and then it is y dot plus 3y and here it is u dot minus 2u. So let's do all these things again. Okay, so sy minus y0 plus 3y and su minus u0 minus 2u. So it is sy, y0 is 2 and 3y, it is su, we are considering it as, so minus minus plus minus 2u, right? Now we will take the y terms s plus 3 and u terms s minus 2, and 3 minus 2 is 1. Now y will be u s minus 2 by s plus 3 and 1 by s plus 3. Okay, so if we put the value of y, so y was u was minus 3 by s minus 2. So minus 3 by s minus 2 into s minus 2 by s plus 3. So these will cancel out and y will be minus 3 by s plus 3 and plus 1 by s plus 3. Okay. Now can you find out y of t? Very simple. It is minus 3 e to the power minus 3t and plus e to the power minus 3t, right? Now tell me what is the steady state value. At t goes to infinity, what is y? This term will go to 0 and this term will also go to 0. So it is 0. Clear to everyone? So the answer is 0. Okay. So I hope now you all will be able to solve the week 3 assignment problems based on these examples. Okay. So that's all for today. If you have any doubt, you can ask or we will meet next week. Okay then. Thank you everyone. We'll meet next week from 6 to 8.